one hangs off the left side of that one. They look exactly alike, but they're not. They're mirror images of each other. Every organic chemical has a mirror image. 50% of them, the active group hangs off the right side, and those are called what? D. And the ones that hang where the active group hangs off the left side is called L. And if you shine polarized light, it will orient the light in the direction of the active side, or the active group hanging off the carbon chain. So remember, carbon organic molecules come in chains. If the active group hangs off the left, it's L. If it hangs off the right, it's D. Why do you care? Oh, because I'm just fascinated and I would love to know lots of interesting things about the universe. No. Because eukaryotic life, complicated cells, visible cells are called complicated or eukaryotic cells, have the enzymes to digest D sugars and L amino acids. So what would be the perfect diet compound for you? L sugar. Look like sugar, cook like sugar, taste like sugar, won't work. You don't have the enzymes. So we work with D sugars and L amino acids. So you should be asking yourself, I made potato salad and I decided I forgot to refrigerate it, and I took it on my picnic, and looks like a little bacteria grew in my potato salad, and we all got the bacteria made out of the same thing I am, so why did my stomach and my enzymes digest the bacteria? Because their cell wall has mostly D amino acids. Gives them a little protection from your digestive enzymes. Eukaryotic life has the enzymes to digest D sugars and L amino acids. What do bacteria have in their cell wall? L amino acids. You don't have enzymes to digest L. Only D. D sugars and L amino acids for humans. Did I just say that backwards? I think I did.
No.
Alright, so remember, we don't have the enzymes to digest L amino acids. Alright, so that's interesting. It's an amusing point. Gives me a way to ask 4 questions. What's a stereoisomer? And you'll say it's a carbon compound where the active group either hangs off the left side or the right side. If it hangs off the left side, it's L. If it hangs off the right side, it's D. What's important? Enzymes can only work on one or the other. Okay, so you have this chain link fence, and gram-negatives only have 2 layers of peptidoglycan. Gram-positives have 100. So that's why the gram stain works. So we're now going to look at the theory behind the gram stain. One interesting thing is that gram-negatives have 2 membranes and a thin peptidoglycan layer. They have a rather separated, notice how closely these phospholipids are bound together in the plasma membrane, but in the outer membrane of gram-negatives, this is called the outer membrane. And only gram-positives have an outer membrane and a plasma membrane. Notice that the plasma membrane, they're all tightly stuck together. Notice there are gaps in the outer membrane. And these little things sticking up here are called lipopolysaccharide A. And they are endotoxins. toxin mean?
Dangerous.
Your ex-wife says you're toxic to my life. Deadly, poisonous, okay? Endo, inside. When a toxin is a part of the structure of something, it's said to be an endotoxin. If it is a poison that's given off into the atmosphere or the liquid around, it's an exotoxin. In gram-negatives, a part of the cell wall, part of the outer membrane itself has an exotoxin. So this is how you can tell if you've got a good doctor or a bad doctor. Some people say it's how you can tell if you've got an HMO or a PPO. You see, what's the job of an HMO? I bet y'all don't know this. To make sure you never come back. Their job is to give you service, preferably preventative service, so you never arrive at all. Or if you do come, you don't come back. And to do all that for the cheapest possible rate. Now, so if you go to a lot of HMOs, and you go and you say, and they look in there, and by looking in there, they can actually tell by, the redness and whether or not there's a coating and all that, whether they think it's allergy, viral, or bacterial. And remember, 80% of the time, it's allergy. 10, 15, almost 20% of the time, it's viral. Few, it's bacterial. Very few. All right, so if they think it's bacterial, and the doctor says, here's an antibiotic, take it, you have a bad doctor. You see, he has no idea what's in there. And if he gives you an antibiotic, there are only two kinds of antibiotics, bactericidal and bacteriostatic. Bactericidal kill the microbe. Bacteriostatic prevent it from reproducing and your body gobbles it up. If he gives you a bactericidal antibiotic and you have a massive gram-negative infection, lipid A is released into your bloodstream, you go into shock and die. Why? It doesn't kill you unless you kill the microbe. When you kill the microbe, lipid A is released into the bloodstream, causes vasopermeability increase, lowered blood pressure, liquefaction of the blood, heartbeat fall, and you die. So, what do the HMO do? They won't give you a bactericidal antibiotic. They will look up a bacteriostatic one that's supposedly broad spectrum. It's supposed to work against everything. Is there anything that works against everything? No. So, what do? They hand it out like candy. Here, take a $5 prescription. It took us $15 to get you out the door. Okay, take it, and that's it. If they give you a bacteriostatic one, and it doesn't work against gram-negative, who cares? It costs them $5. They can't give you a bactericidal one, because it could kill you. So, what do most people do? They wait until they've been sick for 7 to 10 days before they get their appointment. I feel icky, I'll wait a day or two, I still feel icky, I think I'll call the doctor, oh my God, I have to wait 3 more days. So by the time you get to the doctor, you're on day 10. If it's a virus, it won't last but till day 14. So they've given you something, you think it's a miracle, you think, oh, they cured me. Antibiotics don't work on viruses. They don't work on allergies, but guess what? If you go in and you open your mouth and go, I feel awful. They say, it's an allergy, take Benadryl. And you say, I'm not paying $70 to come to this place. I want a miracle cure. Give me an antibiotic. So rather than argue with you, they just hand you an antibiotic. What's bad? The more you use them, the less they work. So the more people that are handed out antibiotics, the less they function in society. You can go to any hospital, take a Q-tip, and go along the floor and find a therapeutic dose of antibiotics, several. Why? When you're taking them enough to have an effect, you are giving it off in a pound of flaky skin, your sweat, your tears, your urine, all have a therapeutic dose. So, why is this bad? Because if you give a bacteriostatic broad spectrum to somebody, it's unlikely to work. But it makes it so that antibiotic doesn't work in the environment. You fill the environment with that antibiotic. So all the bacteria that work on that are gone, and the ones that are resistant fill the environment. So now everybody gets the resistant variety. So what does a good doctor do? Well, a good doctor would go in and they would look, and if they thought it was bacterial, they would call for a test kit. They would bring a sterile Q-tip dipped in sterile water, and they would swab it. They would send it to the lab overnight. The next day, that day, the pharmacist would streak it out on a plate, drop antibiotic disc on it to find out what actually killed, what actually came out of your throat, and the next day, they'd call in a prescription. Now, that costs $70 to $140. HMO costs $5 to get you out of their hair. They give you a broad spectrum, and the more you use them, the less they work for everyone. So you never, never, ever want to use a bactericidal on a gram-negative infection. But remember, unless they take a swab, they don't know if it's gram-negative. Nor do they know what works against it until they take a swab and send it to the pharmacist, who streaks it out and drops this to see what really works on what came out of your throat. So remember, the good doctors, if it's a heavy infection and they think it's bacterial, they will take a swab. The swab will tell you whether it's gram-positive or gram-negative, and the pharmacist will drop like 10 or 20 different discs with different antibiotics on it to see what works best out of what came out of your throat. Not a guess. All right, so let's see how the gram stain works. First of all, this is a gram-negative microbe. What color is it before we do anything?
Pink.
Clear. Remember, it's gram-negative. We haven't done anything. We haven't stained it. We made a smear. So what color is the bacteria? Colorless. All right, so we are now going to add crystal violet. Crystal violet is a huge molecule. And remember, this is full of holes, so it's going to go all the way down here, and it's going to get, since it's partially in alcohol and partially in water, these big molecules are going to end up down here, partially in the plasma membrane and piled up against it. These very large crystal violet molecules. So after you put the crystal violet on the gram-negative bacteria for a minute and shake it off, what color is the gram-negative bacteria?
Purple.
Huh?
Purple.
You put on purple. What is it?
Purple.
Purple. All right? Next, you are going to cross-link. I hate it. Excuse me a second. Don't you hate it when other people use your chalk? Evil, 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 evil children using my chalk. I was a teacher. What is that color chalk? Somebody is. I'm getting hysterical. It's okay. No big. Ooh, why do maybe I have green. Ew, no. Somebody send me an email and tell me to bring some more colored chalk. Alright, I'll have to do with yellow. Oh, here's orange. Alright, so you're going to add the iodine solution. And remember, what's it going to do? It's going to cross-link the crystal violet molecules, making them even bigger. All right? So, after cross-linking with the iodine, what's the next step? Ethanol, alcohol. And remember, alcohol removes stain from one layer every 1 second. And how many seconds are we going to leave it?
2.
2. Well, guess what? It causes the whole outer layer to disintegrate because it is very whatever you call it, uncomplexed. And it removes all this purple. So after decolorizing, what color is a gram-negative?
Clear.
Clear again. And if you put pink, little pink on clear, what color is it?
Pink.
Pink. And if you don't remove it with alcohol, what color is a gram-negative? So that's the theory on why gram-negatives stain pink. Now, let's talk about the gram-positives. First of all, they don't have an outer membrane, that's nice. They have their plasma membrane. And then they have 100 layers of peptidoglycan. All right, so let's do the gram stain. You're going to add gigantic crystal violet molecules for 60 seconds, and they're going to pass through the cell wall just like a sieve. Some of them even landing up in, partially dissolved in the plasma membrane. Okay, so after putting crystal violet on gram-positive, what color is it after you shake off the crystal violet? Purple. Okay, and now you're going to add iodine, and that's going to cross-link the purple. Okay, so after shaking off the iodine, what color is it? Purple. Okay? Now, comes the second part. Everybody hold on to something. You grew up under Ronald Reagan and Proposition 13, where we went from second in the nation in community colleges and high schools to 27. As a result, they got rid of art. So you have no clue that yellow and blue is green. You have no idea that red and blue is purple. But in this case, you have even less of an idea that if you put pink on purple, it is still purple. So if you put pink on purple, and it is still purple, what color are gram-positives after you put on safranin and you don't remove it with a decolorizer? Purple. Gram stain. Thickness of the cell wall. Pink on purple is still purple. And if you can't remove the purple, because remember the decolorizer, what's it going to do? Just remove it from 2 layers. You've got 98 layers of purple. 98 layers of purple on the wall, 98 layers of purple. All right, so you still got purple. All right, so that tells you how the gram stain works. Even if the decolorizer removes purple from 2 layers, you've got 98 left. What if we left the decolorizer on for 2 minutes? What color would it be?
Clear.
Clear. Because it would remove all the purple. But we only leave it on 2 seconds. All right, so this is what a gram-positive cell wall looks like. Of course, it's not 100 layers. Everybody gets tired drawing peptidoglycan. But it's more than 2. And you have your really tight bond here of the plasma membrane. You have many layers of peptidoglycan. Here's a structure that gram-negatives do not have. These are chains of polymers called teichoic acids. And for years and years, we had no clue what they did. It was very annoying because according to the rules of evolution, if something doesn't perform a useful function that is a benefit, it goes away. It disappeared. But in all the years, 4.5 billion years, that bacteria have been on this earth, the gram-positives have had teichoic acids. Yet, we couldn't find a benefit for them. We found a detriment though. That's where viruses that attack bacteria glue themselves to. So, if something is evolutionarily negative, then it should cause that organism to either go extinct or the organism will evolve away from that structure. Yet, the structure remained. And the only thing we could find out about the structure was it wasn't good for the bacteria that had it. It was where viruses attach. So it was very confusing for a number of years until just recently a scientist discovered that these teichoic acid chains that hang off of gram-positives are actually like little sensors. They sense the environment and communicate environmental conditions outside the cell to the nucleus. We always wondered why bacteria, if you put them in a liquid and you put a drop of lemon juice, they would swim away. If you put a crystal of sugar, they would swim toward the sugar. They don't have eyes or pH meters. So how do they know? And the answer is teichoic acids. Now that brings up another question. Gram-negatives don't have teichoic acids, so how do they tell the environment? We don't know yet. So gram-negatives have endotoxin, lipid A, and an outer membrane. Gram-positives have a huge peptidoglycan layer, no outer membrane, but they have teichoic acids. The teichoic acids provide communication with the outer environment. Then we have that other bacteria, that annoying one, the Mycobacterium. Mycobacterium and Nocardia have this structure, and it's just purely pisses me off because it has 2 layers of peptidoglycan, but it has a huge fat layer. So by the gram stain theory, what should it stain? Gram-positive or gram-negative? Gram-negative. Thin cell wall. Should be gram-negative. It's not. It stains gram-variable on the positive side. 80% of them will stain gram-positive. Oh, that's so annoying. So, the next question is, why? And the answer is barbecue. You didn't know the answer was barbecue, did you? Okay. Labor Day was here. Labor Day in the old days, I used to go to my sister's house. My sister, I love her so much. She is an amazing woman. She likes hoochie coochie a lot, though. 7 kids. You've got to like a lot of hoochie coochie. I asked her what kind of birth control her and her husband used after the 5th one. And she said condoms. And I said, and where are you putting the condom? On this head or another? And she said, no, we use rhythm. And I said, rhythm? She said, yes, I plot my period on a calendar, and then we just don't use anything during the safe times. And I said, and see how safe they've been. We call people who use the rhythm method of birth control parents. So anyway, I said, so how's that working out? She said, well, it was great growing up. I love babies. Babies are cool. Except they grew up. And once they turned into teenagers, this one didn't turn out as well as I expected. You see, her kids go from 32 to 16. And she said, the amazing thing is that I discovered that children are fun as children and babies. They're not so much fun as teenagers. You see, one of them has a life crisis every 2 weeks. So since I have 7, that means 28 out of 30 days, one of my kids is having a life crisis. The kind where they're getting cancer, they're getting arrested, their house is being repossessed, their car has been totaled. Some major life crisis on one kid every 2 weeks, which takes up every month of every year. And I said, She said, yes, I was hoping I could trade them in for hamsters after they turned 13. Didn't work out. So anyway, every Labor Day we got together. And my dad was not much of a barbecuer. It was my mom that loved to do the barbecue. And of course, she didn't get those that little ground beef, what do they call it, 10% lean, 90% lean. No, that's cardboard. She goes out and gets that 70%, 30% fat, really fatty Angus beef, and mix it with a little oatmeal, a little egg, little onions, and makes these big patties this thick, And she's out there cooking the hamburger, and of course she's wearing this beautiful cotton apron that says world's best barbecuer on it. And she's just so happy and gossiping with everybody, and the center of attention, which my mom loved. And she's flipping the burgers, and there's always somebody talking to you when you're doing that. And you may give one a little extra flip, and you're, oh, shh! And you use the apron to bounce it back onto on the grill, and everything's safe. But you got the big greasy spot. And then, have you ever had kids around at barbecue time? Yes. They get the squeeze ketchup and the squeeze mustard and the squeeze mayo, and they're around fighting with it. So mom gets this huge big mustard stain right on where the hamburger grease has soaked through her apron. Will she ever get it out? I know you guys don't know this, but if you get grease, particularly on cotton and organic fabrics, if you don't run in and put some detergent on that and some spray and wash, kiss it goodbye. And if you get a stain on top of grease, forever. It's not like marriage. It's forever, the stain. You can't get it out, ever. That's why the Mycobacterium and nocardia that have this fat layer stain gram-positive. Why? The crystal violet is dissolved in alcohol and water. And since it's dissolved in alcohol and water, it will penetrate this fat layer in 60 seconds. It will even get down here. Now, you add the iodine and it cross-links it. then you add 2 seconds of alcohol, is it ever going to get it out of the lipid? No. So it's going to remain purple. Even if you put the saffron on it, it's still purple. So why is it 80 to 90% gram positive, but every once in a while you'll get 10% of them are pink? Answer, because crystal violet is dissolved in water and alcohol. Sometimes this layer repels it. And the last thing you put on is saffron, which is dissolved only in alcohol, it might stick here. But most of the time, they stain purple. And just for fun of it, in the last class, I did a Mycobacterium gram stain so that you can see how many of them are purple and how many of them are pink. Looking through here. When you get a chance today, come by and look at it. Mycobacterium is a nasty genus. It's the genus, there are somewhere around 290 species of Mycobacterium. 3 of them are friendly. Only one of them we use in this class, and most of Mycobacterium there's like 57 different kinds of human tuberculosis. Then there's 4 different kinds of cow tuberculosis. There's 18 kinds of bird tuberculosis, all of which people can get. Used to be when people would get AIDS, if they didn't die of AIDS, they died of Mycobacterium avium intracellulare, which is bird tuberculosis that destroys your internal organs. Babies and old people can get Mycobacterium avium intracellulare. This is why you can't go to Cuba or Costa Rica and buy a parrot and bring it back, because they have to be tested for bird tuberculosis, which people with rundown immune systems can catch. And of course you can get cow tuberculosis, which is why in the 1700s, did you see advertisements for fresh whole milk? No. People would sell cheese, cottage cheese, yogurt, but they would never sell fresh milk. No one drank fresh milk from a cow you didn't know personally. Why? Almost every cow disease people get. And when a cow has tuberculosis, you'll get the tuberculosis. So, what else is Mycobacterium? Leprosy. Remember the Bible? The part where your pieces fall off, fingers fall off, toes fall off, your nose falls off. You scratch your nose and it comes off in your hand. Scratch an ear, there's an ear. Horrible disease. Mycobacterium leprae, Mycobacterium tuberculosis. Then there's one, Mycobacterium pseudotuberculosis. What do you think it is? Fake human tuberculosis. It looks like human tuberculosis. It grows like it. It stains like it. But it won't kill people. However, you can't tell it from the real one without DNA testing. So if I brought it in here for you to use, they'd shut down the block until they proved it wasn't the human one. So you can't use that one. Pseudotuberculosis. So the only one we use is called Mycobacterium smegmatis. Mycobacterium smegmatis grows under the foreskins of human males. Yeah, I know, it's disgusting. It's where the word smegma comes from. And it is harmless except to people that have no immune system at all. It has been linked with trying to think of the disease, Crohn's disease, but only in people with no immune system. It looks like tuberculosis, it grows like tuberculosis, it stains like tuberculosis. And since it's the only one that is safe that we can use without having the health department shut us down, that's what we use. By the way, it's in the air all the time. If you leave any tube open, you're going to get it in there. Why? Men don't wash their hands after going to the bathroom. So it's floating in the air, in the dust at all times. What does it look like? In a culture, if you do a stain and you see this, you see a lot of these things, that's a spicule. It's a dried Mycobacterium smegmatis. Sometimes you'll see this, same thing. Smegmatis from air contamination. What does it look like under the microscope? It looks like a very long, sharp, one end is a sharp point, and the other one is blunt. And in the blunt end, it has the nucleus, so it looks almost like it's round, like this. It looks like it's clear with a round end. And a lot of people say, oh, it's round. It's not. You're missing the rest of the rod. So when you see this, they look at its shape. It's a sharp pointed rod. 80 to 90% of them will stain purple, a few will stain pink. You officially, if I say, what's the gram stain on that? You'll say it's gram positive. Because on the gram stain, it goes by the majority rules. So if 80% of them are purple, what is it going to be? Gram positive. Last thing I want to tell you about the gram stain. And that is reading it. What can give you trouble? Well, we already know that Mycobacterium might give a few people trouble because a few of them will be pink. But you can get rid of that trouble by remembering what? You're looking at a color under there, and some of them are pink. And I ask you, is it gram positive or gram negative? What are you going to say? Positive, the majority rules. All right? Now we have one other little problem. And the other little problem is bacillus. The word bacillus means rod, and they're rod-shaped, and they all kind of look like hot dogs. There's a few of them that look like this. But most of them look like some sort of train. You probably saw some of them under the teeth thing. And one of the things you'll notice is they all seem to have an empty hole. That empty hole is where an endospore, not spore, but endospore. Endospores are survival structures. When times get bad, too dry, too hot, too wet, too anything, too little food, too much food, too wrong pH, whatever. When times are bad, the cell, the vegetative cell, that's the part that makes the endospore, falls apart, and all that's left is the endospore. When times get better, that one endospore will generate a whole rod again. So if one endospore makes one rod, is that reproduction? 1 to 1? If you bud off and make one of you and you die, is that reproduction? Remember? 2 have to get together and make an extra one. 3. So in other words, each one of these has to make more than one rod. If one deteriorates and makes one, you've still got one. It's not reproduction, it's survival. And by the way, we have found some of these endospores that are over 6,000 years old in the pyramids, and they grow. You can pull them out and get them to grow and start reproducing. Now, why am I bringing this up under the gram stain? They have a thick cell wall, so they stain what color? Purple. Except when they're falling apart. When they fall apart, the purple leaks out and they become pink. So if you see something that looks like this, So you see a bunch of pink pieces. You see some egg-shaped things that look sort of light purple. And you see lots of purple hot dogs on top. Remember, it's what's on top that stains. Underneath are pieces of cells that have fallen apart, and the crystal violet leaks out. So when you stain old bacillus cultures where they've fallen apart, you may find more pink pieces than purple. But remember, it's the ones on top that matter, where they're the whole rod and not just a piece. And that's gram-positive. Okay, so that's all the theory about it. Let's look at a few pictures, and then I'll do a demo, and then you'll do as many as you can get done tonight, and what you don't get done, we'll do next time and introduce the acid bath. So the next thing we're going to look at is just a few pictures and see if you are smart. Okay? What is that? What color is it, first of all?
Purple.
Purple. Good. Now the structure is two circles stuck together, like two kidney beans that have been pushed together. So that is a coxy. These are called diplocoxy because they're always in twos. See? Now there might be one right there, but generally speaking, almost always they're in twos. Sometimes they can even be in fours. All right, so let's look at some other ones. All right, so I'm going to pull up this one. Oops, somehow I didn't get it. There we go. Hold on a second while it continues to load. Trying to make it bigger, but it's not wanting to do that. Sometimes I can do it, sometimes I can't. But anyway, can anyone tell me what, first of all, you see anything perfectly round?
No.
No. So, what's the predominant color?
Purple.
Purple. This is smegmatis. This is mycobacterium. Yeah, there are some pink ones, and they are rods. But the overwhelming majority is purple. So 60–70% of that's purple. So you're going to say that one is a gram stain. How can you tell it's gram? Because the only two colors you see is purple and pink. How do you tell it's a rod? It's not perfectly round. How do you know whether it's gram positive or gram negative? You go by the majority rules. All right, look at this one. This is that one that I was telling you about that's a big pain in the butt. Whoops. This is the one where they got old. So what do you see there? You see some purple hot dogs, and you see some empty holes in the purple hot dogs, and underneath you see pink random pieces. Remember, bacteria are all going to be sort of like buying a package of hot dogs. They're all going to be the same size and shape. If you see random shapes, that's dead ones or things falling apart. So, first of all, how do you know what stain this is? The color is purple and pink. If it looks black, remember that's purple, it's just the projection. So purple and pink is the gram stain colors. What's the shape of one? Hot dog. All right, so you know it's a rod. Most of these are purple, particularly the ones on top. Anything underneath, who cares? Remember, you're looking at the ones on top. So that is a gram-positive rod. Okay, let's go back and see if we can find something. Let's see what else we can find here. This one. Rods, all pink. Rod, nothing's perfectly round. Remember, if you see one, it's not that, we're not talking about one. Look at this one. Rod, all purple. So what is it? Gram-positive rod. Okay, let's see what else we can look at down here. That one. Purple coccidian chains. Streptococcus is the shape, and it's purple coccidian chain. So yeah, you haven't looked at them yet. Don't panic, but hopefully you'll be able to pick out which ones are the gram stains. There's a gram stain. Purple rods, pink ones are falling apart. You can even see some of the empty holes in the purple rods as they're beginning to fall apart, making the end of spore. So see if you can look over some of these and practice. There's smegmatis again. How do I know? It's a sharp-ended rod. One end is sharp, the other one is fat. There's a few pink ones in there, but the majority is purple. So you're going to have to give that a try. And what I would do if I were you is, when you're looking at these and giving yourself a try, is go to the Lab Practical 1 and go down to problem staining. Problem stains. And it will discuss each one and what the problem stain is for it and give you a picture of it. Give you something to work with. And then you might even want to do name the stain game, where you look at the pictures and see if you can pick out which one's the gram stain. Anyone have an idea? K, that's the gram. N, gram stain. Q, P, R, S, all the ones that are purple. Not this one's blue. That's purple. Purpley black, I guess is the best way. That's purple. So all those were the grams. The rest are other stains that we're going to look at later. So give yourself a few little things. Tonight you're just going to practice. Do not panic yet. Panic later. I'll tell you when to panic. The panicking can become at another time. All right, so now I'm going to do a gram stain for you, and then you're going to do gram stains until you throw up, die, or 9 o'clock. Even 9:15 if I'm still got some energy. All right, so anyone have questions about anything we've been over so far as I'm doing my little prep? This still water, doesn't it? Try disinfect it. It's always priming. I forget to get one of these, it saves so much time. By the way, don't see them on.
What was the Morgan for that? What was the Morgan?
Hey!
is the Hicks cell. And it doesn't have.
Yeah.
Meaning over the gram-negative.
That's what he was just saying.
That's sugar. I miss it.
It's in the slide. In PowerPoint.
Oh, they have this one.
Don't you want to see
Yeah,
how
that's the one
it's
he
ran?
went over.
Exactly.
Yeah, but they go with a negative, gram-negative cell wall.
On the board now.
All right, so, okay, who's got a brain? Anybody? Good memory? You look like you do, you look like you do. Make sure, when I leave tonight, tell me I have to print out a roster. That's what she was telling me. They're coming to get me with little coats, the white coats.
Black.
And they're gonna, I forgot to put out a roster, turn in a roster. All right, so we are going to start this now. Don't forget to write down on your tabletop after the lecture portion. Remember that in the lab portion, you have to get rid of all food and drink from visible light. It cannot be visible to anybody. Ooh. Make yourself a little straight staining area. Slap on some gloves. Notice my gloves seem to be disappearing one to one. You need to have your gloves and you need to have your coat on during lab. You can pick up one of the tubes. Only one at a time, preferably you and your lab partner use the same tube each time. Okay. Watch me do everything. Come over here, make sure you make a nice little paste. If you don't have yours washed, remember, take them home and wash them so we don't have to waste time doing this next time. Make sure it's good and rinsed, not slippery. Okay, test it to make sure it's clean. 1 ton, 2 ton, 3 ton, 4 ton, 5. Dry it. Where are you going to put the circle?
Middle.
Sit down. Watch me. Put the circle on the bottom, a little bit past halfway. And I'm going to do E. coli. So I'm going to put my circle, and I'm going to put EC. I don't know what it is. And I'm going to place it face down on my wooden block. Going to take out my loop and make sure it doesn't have any weird wires sticking off in weird directions or look like an L. It'll be a straight line like that. Turn my gas all the way on. Adjust here for the flame. Hold it, press. Does that. Shut down the flame a little bit. Keep that burner. There we go, then make it hot. A cone within a cone. Keep this to red hot. The whole length. Leave the loop in. Count to 10, 1,001, 1,002, 1,003, 1,004, 1,005, 1,006, 1,007, 1,008, 1,009, 1,010. Remember to share your Bunsen burner with your lab partner, because it's going to get so hot in here you can't breathe. You'll love that. Put the drop there. You really don't need to heat your loop again, but it's very, very wise to always be in the habit of every time you use the loop, you heat it. So I always heat it again. Remember the cone within a cone, so the top of the inner cone is where it's the hottest. 1,001, 1,002, 1,003, 1,004, 1,005, 1,006, 1,007, 1,008, 1,009, 1,010. Pick it up by the glass. Flame the lid. Hold it in your little finger. Pull it out. Flame the lip. Orient it so it's going uphill. Do not pick it up at the beginning. Go past halfway. Put it down and brush the surface. Just brush it. Just like you're brushing a beautiful girl's hair. You don't do this to her hair. You go past, pull, past, pull. Now, if you can see it in here, you got too much. So you want just enough to barely detect you've got something on the loop. Flame the lip, flame the lid, set it down. Pick this up and turn it over and over, and you'll see the stuff coming off the loop. As you're turning it over and over, then spread it as wide as you can on the entire slide. The wider you spread it, the quicker it's going to air dry, the thinner and nicer it's going to be. Heat the loop to red hot again, put it down, pick up your fan or a piece of cardboard and dry where? In the circle or the whole slide?
The whole slide.
In the circle is all that matters. And if you see it withdrawing, you see mine withdrawing a little bit, so that means it wasn't the absolutely best wash slide. It'll be all right, but no. I would give myself a B minus. One of each, and do one at the time until you get it signed, or I tell you do it again. By the way, the most famous words in microbiology lab are, do it again. It's not right, do it again. If when this is dry, I can hold it up and she can see it, it's too thick. So I can already tell it's right on the edge of being a little bit too thick. It should be barely detectable, like I would have to go, oh yeah, I can see it. Not, oh, I can see it. Alright, so this is now air dry. I don't care about anywhere but the circle. Pull my wrist out, touch it, touch it. Now ready to stain. Coming off the Bunsen burner, lay that down, take the crystal violet, pick it up by this, like that. 2 drops. Enough to cover the circle. Did you guys look at the on the website? There, I put a couple of videos on the theory of the gram stain and how to see how they work and the theory behind it. Good. 60 seconds, so I put that on at about 20 after, and we'll do it. Questions about anything that I talked about so far while we're waiting for our little thing to do? Everybody sign the roll? Okay, and also don't forget if you're taking a new seat number, be sure to put the seat number by there if you weren't here before. Periodic life has the enzymes to digest D sugars and L amino acids. What do bacteria have in their cell wall? L amino acids. You don't have enzymes to digest L, only D. D sugars and L amino acids for humans. Did I just say that backwards? I think I did.
Oh, yeah.
All right, so remember, we don't have the enzymes to digest L amino acids. All right, so that's interesting. It's an amusing point. Gives me a way to ask 4 questions. What's a stereoisomer? and you'll say it's a carbon compound where the active group either hangs off the left side or the right side. If it hangs off the left side, it's L. If it hangs off the right side, it's D. What's important, enzymes can only work on one or the other. Okay, so you have this chain link fence, and gram-negatives only have 2 layers of peptidoglycan. Gram-positives have 100. So that's why the gram stain works. So we're now going to look at the theory behind the gram stain. One interesting thing is that gram-negatives have 2 membranes and a thin peptidoglycan layer. They have a rather separated, notice how closely these phospholipids are bound together in the plasma membrane, but in the outer membrane of gram-negatives, this is called the outer membrane. Oh, I still feel icky. I think I'll call the doctor. Oh my God, I have to wait 3 more days. So by the time you get to the doctor, you're on day 10. If it's a virus, it won't last but till day 14. So they've given you something. You think it's a miracle. You think, oh, they cured me. Antibiotics don't work on viruses. They don't work on allergies. But guess what? If you go in and you open your mouth and go, they say, it's an allergy, take Benadryl. And you say, I'm not paying $70 to come to this place. I want a miracle cure. Give me an antibiotic. So rather than argue with you, they just hand you an antibiotic. What's bad? The more you use them, the less they work. So the more people that are handed out antibiotics, the less they function in society. You can go to any hospital, take a Q-tip, and go along the floor and find a therapeutic dose of antibiotics, several. Why? When you're taking them enough to have an effect, you are giving it off in a pound of flaky skin, your sweat, your tears, your urine, all have a therapeutic dose. So, why is this bad? Because if you give a bacteriostatic broad spectrum to somebody, it's unlikely to work. But it makes it so that antibiotic doesn't work in the environment. You fill the environment with that antibiotic. So all the bacteria that work on that are gone, and the ones that are resistant fill the environment. So now everybody gets the resistant variety. So what does a good doctor do? Well, a good doctor would go in and they would look, and if they thought it was bacterial, they would call for a test kit. They would bring a sterile Q-tip dipped in sterile water, and they would swab it. They would send it to the lab overnight. The next day, that day, the pharmacist would streak it out on a plate, drop antibiotic disc on it to find out what actually killed, what actually came out of your throat, and the next day, they'd call in a prescription. This one hangs off the left side of that one. They look exactly alike, but they're not. They're mirror images of each other. Every organic chemical has a mirror image. 50% of them, the active group hangs off the right side, and those are called what? D. And the ones that hang where the active group hangs off the left side is called L. And if you shine polarized light, it will orient the light in the direction of the active side, or the active group hanging off the carbon chain. So remember, organic molecules come in chains. If the active group hangs off the left, it's L. If it hangs off the right, it's D. Why do you care? Oh, because I'm just fascinated and I would love to know lots of interesting things about the universe. No. because eukaryotic life, complicated cells, visible cells are called complicated or eukaryotic cells, have the enzymes to digest D sugars and L amino acids. So what would be the perfect diet compound for you? L sugar. Look like sugar, cook like sugar, taste like sugar, it won't work. You don't have the enzymes. So we work with D sugars and L amino acids. So you should be asking yourself, I made potato salad and I decided I forgot to refrigerate it and I took it on my picnic and looks like a little bacteria grew in my potato salad and we all got the bacteria made out of the same thing I am, so why did my stomach and my enzymes digest the bacteria? Because their cell wall has mostly D amino acids. Gives them a little protection from your digestive enzymes. And only gram-positives have an outer membrane and a plasma membrane. Notice that the plasma membrane, they're all tightly stuck together. Notice there are gaps in the outer membrane. And these little things sticking up here are called lipopolysaccharide A. And they are endotoxins. What's toxin mean?
Dangerous.
Your ex-wife says you're toxic to my life. Deadly, poisonous, okay? Endo, inside. When a toxin is a part of the structure of something, it's said to be an endotoxin. If it is a poison that's given off into the atmosphere or the liquid around, it's an exotoxin. In gram-negatives, a part of the cell wall, part of the outer membrane itself has an exotoxin. So this is how you can tell if you've got a good doctor or a bad doctor. Some people say it's how you can tell if you've got an HMO or a PPO. You see, what's the job of an HMO? I bet y'all don't know this. To make sure you never come back. Their job is to give you service, preferably preventative service, so you never arrive at all. Or if you do come, you don't come back. And to do all that for the cheapest possible rate. Now, so if you go to a lot of HMOs, and you go and you say, and they look in there, and by looking in there, they can actually tell by, the redness and whether or not there's a coating and all that, whether they think it's allergy, viral, or bacterial. And remember, 80% of the time, it's allergy. 10, 15, almost 20% of the time, it's viral. Few, it's bacterial. Very few. All right, so if they think it's bacterial, and the doctor says, here's an antibiotic, take it, you have a bad doctor. You see, he has no idea what's in there. And if he gives you an antibiotic, there are only two kinds of antibiotics, bactericidal and bacteriostatic. Bactericidal kill the microbe. Bacteriostatic prevent it from reproducing and your body gobbles it up. If he gives you a bactericidal antibiotic and you have a massive gram-negative infection, lipid A is released into your bloodstream, you go into shock and die. Why? It doesn't kill you unless you kill the microbe. When you kill the microbe, lipid A is released into the bloodstream, causes vasopermeability increase, lowered blood pressure, liquefaction of the blood, heartbeat fall, and you die. So, what do the HMO do? They won't give you a bactericidal antibiotic. They will look up a bacteriostatic one that's supposedly broad spectrum. It's supposed to work against everything. Is there anything that works against everything? No. So, what do? They hand it out like candy. Here, take a $5 prescription. It took us $15 to get you out the door. Okay, take it, and that's it. If they give you a bacteriostatic one, and it doesn't work against gram-negative, who cares? It costs them $5. They can't give you a bactericidal one, because it could kill you. So, what do most people do? They wait until they've been sick for 7 to 10 days before they get their appointment. I feel icky, I'll wait a day or two.